Hello, geometry students. Today we are doing 7-5 proportions in triangles. And our learning target for today is you will use the side splitter theorem and the triangle mid-segment theorem to find lengths and sides, or lengths of sides and segments of triangles. And you can see these two theorems down here. So you have the side splitter theorem and you have the triangle mid-segment theorem in your notes. Your vocabulary today is corresponding angles. We've been talking a lot about corresponding. It means that they're matching. They're in the same spot. And we'll also review transversal. Remember, a transversal cuts parallel lines. So if you have parallel lines, and we can denote that using an arrow like that on each line, then this line that I'm drawing through it is a transversal. And in Spanish, it's the same thing. Transversal is transversal. And corresponding angles is ángulos correspondientes. Ángulos correspondientes. So what is the side splitter theorem? If a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So you can see that we have two parallel lines, and this one is intersecting at M and N, parallel to the base AC. Then they're saying that CN is proportional to AM, and B is proportional to NB. All right, so these sides are proportional to these sides. So you can set up a proportion. In Theorem 7-6, if a segment joins the midpoints of two sides of a triangle, so this would be the midpoint here and here, then the segment is parallel to the third side and is half as long. So these sides are half as long. So GH is half of DF. And then you can also say that GH is parallel to DF. Okay, so they're parallel. Example 1. Explore proportions from parallel lines. In triangle JLN, if LN is equal to 9.6, so we're looking at this piece, is equal to 9.6, what are LM and MN? Are the sides divided proportionally? Well, we can see right now, I'm going to write this as part of our proof, that KM is parallel to JN. Next, we want to set up a proportion. So we'll take the little triangle, so that we'll use the 3, and that is going to be proportional to LM. And then I'm going to take the whole side, which is 8, because 8 will be proportional to 9.6. And we can do our cross multiplication and division to figure out what LM equals. So 3 times 9.6 is 28.8, divided by 8 equals 3.6. So LM equals 3.6. Now that we know that, we can figure out So we'll use 3 is to 3.6 because that's the KL. KL is to LM. As we have 5, which is JK, is to MN, which we're looking for. So we're going to cross multiply, which is 5, let me grab my calculator, 5 times 3.6 is equal to 18, divided by 3 is 6. So MN equals 6. And that's example 1. Let's see. It's asking, are the sides divided proportionally? And we can say yes, we found those sides using proportions. And this was just part of our proof, because those sides were parallel and it was shown in the diagram. So yes, we used proportions to find the missing segments. Let's think about this next problem. It's saying that side BD bisects sides AC and CE. And you can see that because this piece 5 and this piece 5 are the same, and this piece 6 and this piece 6 are the same, so it's bisected. Is side AE parallel to BD? And the way that we would show that as parallel is on those lines, AE and BD, we would draw arrows. And that's our question. Are they parallel? Well, if the sides are proportional, then it would be parallel. So I would say that BC corresponds to CD and BA corresponds to DE, and those are equal to 5, and this side's equal to 6, and so we want to see if the cross products are equal. Well, it looks like they are, because 5 times 6 is 30, and 5 times 6 is 30, and those are equal. So yes, BD and AE are parallel. Or you could write it as BD is parallel to AE. All right, get ready to turn your page. For example 2, let's use the side splitter theorem. They're asking us, what is the value of x in PQR? So x is right here. Because x is there, we have to use this side as well. And then I just have to choose another piece of the triangle, but I actually can't use 12 and 9 because it's not showing that y is parallel to z, or that z is parallel, but they do show that z is parallel to 30. So that means that we should actually use all of these. I'm not sure if it would work with just the 3 and the 4, so I'm not going to risk it. But the 12 and 4 become 16, and the 9 and 3 become 12. So we're going to set up a proportion that from P to S, which is x plus 2, corresponds to the x side, which is TR. Setting up a proportion, and we'll use the 16 here, which is SQ, and we're going to use the 12 here, which is QV. So give you a second to think about that, how we got those. Now we want to cross multiply the yellow highlighter. We're going to cross multiply these, and we're going to cross multiply these. So when I multiply 16 times x, that's easy, I get 16x. Then multiplying the 12, I want to multiply it with parentheses, and I'm going to have to distribute. And then we'll just solve for x, and it should work out just fine. So 16x is equal to, distributing, we get 12x plus 24, because 12 times x and 12 times 2. Distributing. From here, I will subtract 12x from both sides. That gives me 4x. 12x's cancel. We have 24. Divide by 4, x equals 6. And that answers our question. And so that would be 6, and the other side would be 8. And that's how the side splitter theorem works. Let's do a try it. Given that AD equals 3, so I want you to label your diagram, BD equals 4, and BE equals 8, find CE. Now I want to pause the video here. For example 3, we're asked to find a length. A reflecting pool is separated by walkways parallel, and that's a key word, parallel, because if they weren't parallel, we can't use our new theorem, to Lincoln Street and Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X represent? All right, so in the picture, find X. It's right here. Now, to solve for X, you're going to want to set up a proportion where we will cross multiply and divide. So I want to use X is to 60 as 24 is to 72. So X is to 60 as 24 is to 72. Now we'll take out our calculators and we will cross multiply and then divide by 72. So 60 times 24 divided by 72 equals 20. So X equals 20. And we should put our units. Feet. 20 feet. For these practice problems where it's asking what is X? What is X? I want you to complete these practices, and you can talk to your partners about it, but you'll want to set up proportions. All right? And that's your ticket out the door.